Okay, thank you for listening today. My name is Jay Martin. I'm a professor of ecological engineering at Ohio State University. I also serve as the lead faculty for the Field to Faucet program at Ohio State. And today I'd like to introduce the Field to Faucet program and talk about end-to-end solutions for western Lake Erie Basin. I think this slide is really important. We've all heard a lot about the toxic algae that happened in Lake Erie in August of 2014 and how it shut down the drinking water for the citizens of Toledo for 3 to 4 days in August of 2014. This is a really important event because it brought the harmful algal blooms to national prominence. It affected state legislation. It really took this from an issue that affected beachgoers and fishermen to something that really affected everyone. It led to a lot of important things, and it actually led to the founding of the Field to Faucet program that I'm speaking of today. So with that in mind, I think it's important to note that Toledo is not the only municipality to suffer from drinking water bans. Also in 2014, Monroe, Michigan, and Pelee Island in Canada suffered from drinking water bans, and going back to 2013, Carroll Township suffered from drinking water bans. So while we try to address the harmful algal bloom problem by looking at land management issues and what's happening on the field, it's very important for us to realize that it's going to take us 5 to 10 years to make those changes. And while those 5 to 10 years pass by, we need to maintain safe drinking water for the citizens that live along Lake Erie. So that's the reason we need to look at end-to-end solutions from the field to the faucet. Another important impact that I'd like to highlight here is something in the middle between the field and the faucet, and these are impacts on the aquatic ecosystem. And a lot of this work is being done by Stu Ludson and others at the Aquatic Ecology Laboratory at Ohio State. And so one of the things that we're noticing is changes in the food structure and the food web that supports Lake Erie. So as there's more cyanobacteria, and cyanobacteria are the organisms that cause the harmful algal blooms, as we see more cyanobacteria, we see less of the beneficial algae that the fish can eat. And so as we see less of this beneficial algae that supports the food web that leads to smaller fish that bigger fish such as walleye and yellow perch eat, we're seeing changes. So we don't know right now if these changes are impacting the walleye and yellow perch, but we do know that there is a change if there's more cyanobacteria and less beneficial bacteria, or less beneficial algae, excuse me. The other change that we're seeing is we are picking up traces, minute concentrations of microcystin in game fish in Lake Erie. So we have measured concentrations of microcystin in walleye and yellow perch. I do want to emphasize that these fish are still safe to eat. These are very low concentrations, so it is safe for the public to eat these fish. But we are picking up concentrations of microcystin in the game fish. We're not quite sure how it's getting there, if it's due to a seasonal exposure, if it's due to a lifetime exposure, but we are seeing some impacts on the aquatic ecosystem. So this slide, I just want to make the point that this isn't just an issue for Lake Erie. This is something that's impacting water bodies across the state of Ohio. So this is an image from 2013. You can see in that year there were water advisory postings for 22 water bodies across the state of Ohio. But in 2015, where we are now, I'm sure I could make a similar map. There's already been warnings issued for many inland water bodies across the state of Ohio: Buckeye Lake, Grand Lake St. Mary's, lakes in southwestern Ohio as well. So Field to Faucet, while the focus is on Great Lakes, especially Lake Erie, we're also looking across the state at inland water bodies as well. So with that being said, I wanted to talk a little bit about the Field to Faucet approach and what are some of our goals. As I mentioned, end-to-end solutions are very important for us. So in the fields, we want to maintain a sustainable food supply that can result in economic benefits to farmers. That's very important for the state of Ohio and our economic livelihood here. At the same time, we need to maintain safe drinking water for our citizens. So looking at the end-to-end solution and looking in between there at the aquatic ecosystem, looking from the field to the faucet. We want to accelerate applications. So soon I'm going to talk about research that's being funded from field to faucet. So it's very important to take that research, accelerate the movement of that research from the laboratory, from edge of field sampling, and get that to applications on the field where we can limit the amount of phosphorus getting into Lake Erie. It's also very important to collaborate with other agencies and universities, and that will allow us to more quickly identify and address knowledge gaps. It's also important to realize that we're not reinventing the wheel here. On the right-hand side of this slide, I have a list of topics that we have a lot of past and ongoing expertise within the state of Ohio and within the Midwest that we can pull from as we make these contributions to improve water quality across the state and in Lake Erie. A very brief timeline of the Field to Faucet program. It was launched in the fall of 2014 with $1 million in support that was provided by the College of Food, Agriculture, and Environmental Sciences. The program was launched by Dean Bruce McPherson of the College of Food, Agriculture, and Environmental Sciences. In November 2014, Ohio State and University of Toledo were selected to manage $2 million, which was provided by the Ohio Board of Regents. These projects have begun. Sea Grant, as you can see here, is playing a pivotal role in this. They're actually leading the management of these 18 projects, actually. And in March of this year, 5 research projects were launched that were supported by the $1 million that was invested from the College of Food, Agriculture, and Environmental Sciences that I'd like to describe now. So as you see here, this diagram is very good. It shows that our focus is looking from the field to the faucet. So the first 2 of the 5 projects I'd like to talk about are highlighted with circles here, and these involve the management of data and information. So the first one in the middle is a data co-op. We have a lot of great information about water quality, water flow, and farming practices across the western Lake Erie Basin. What we don't have is a central way to organize that information. This data co-op would provide that central way to organize that information so researchers such as myself and others would have an easy place to pull that information from. We'd also like to get that information in the hands of farmers, so this is where the other circle comes into play, the field management applications. With this, farmers will be able to see how their different practices can impact water quality. They can also see how different practices will impact agronomic yields and how their neighboring farmers are using different practices to improve water quality or improve agronomic yields so that farmers can benefit from this data sharing as well. Another thing we're trying to do with field management applications is get farmers information about impending storms in their hands, in the cabs of tractors, so that they can realize when and when not to apply fertilizers in a very quick and efficient way. Moving on, there's 2 other important projects, microcystin detection and bloom detection. These are both focused on maintaining safe drinking water. While we're trying to address the issues on the fields, that's going to take 5 or 10 years probably to reduce the amount of phosphorus getting into Lake Erie. As I said before, it's going to be vitally important to maintain safe drinking water this time. One of the limitations right now is the ability to know the concentration of microcystin in real time. Right now, drinking water treatment plants take a sample of water, they send it to be analyzed, and 12 to 24 hours later they get the results from that. They find out how much microcystin is in that water, and then they try to treat the water flowing through their plant based on information that's 12 to 24 hours old. So if we can develop real-time microcystin detectors, this will be great. This will be a great help to drinking water treatment plants as they determine how to best treat the water. One of these is a microcystin detector that would actually go in the water and tell you how much microcystin is in the water. The other one is using UAVs to detect blooms and determine how much microcystin is in the water. The last project that we funded I'd like to talk about is manure recycling. So here the idea is to remove some of the nutrients from manure before we put it on the field so that we can strip some of the nitrogen and phosphorus from that manure so it can be put onto the field without as much of a risk of nitrogen or phosphorus running off. This is something that's probably more important for areas such as Grand Lake St. Mary's and inland lakes. Grand Lake St. Mary's, some of our For Lake Erie, some of our research shows us that just about 10% of the farmers actually apply manure to their crops. Most of it's synthetic fertilizer application for the western Lake Erie Basin. But inland lakes such as Grand Lake St. Mary's, there's an abundance of livestock, there's an abundance of manure. A lot more farmers apply manure to their fields in these settings. So in these areas, it will be great if we can develop ways to strip out some of that phosphorus and nitrogen before the manure is applied to the field and limit the amount of nutrients that can run off the field. So those are the 5 projects that we funded initially from field to faucet, and they actually began in March 2015. Other current actions that we're pursuing in the field to faucet program right now, there's a regional conservation partnership program, part of a USDA award, and here we partnered with Michigan and Indiana to earn an award of $17.5 million. It's going to be available for cost shares. This will allow farmers to implement different BMPs such as drainage water management, things that they can use cost shares for. And I just want to note that the enrollment period is open now through July 17th for farmers to enroll in this program. We're also developing a weather risk management tool. This will warn farmers of impending storms. This is a partnership between NOAA, Ohio Department of Agriculture, and Ohio State University. And lastly, we're pursuing the development of a best management handbook. So there's a lot of different best management practices out there, and it's a little bit confusing. It can be confusing for farmers to know which one of these best management practices might be the best for their farm. So the idea of this tool is for farmers to be able to input information about their farm, such as their slope of their field, their soil type, the type of crop that they're farming, the crop rotations they're using, and based on that to recommend what BMP would be best for them in terms of water quality improvement, also in terms of economic impact on their farming operations. So these are some of the other current actions that we're pursuing right now with the Field to Faucet program. We have a lot of great partners for the Field to Faucet program, which are really important to us, include government agencies and also academic institutions. And lastly, I'm going to close by talking about some of the next steps for the Field to Faucet program. So we definitely want to manage our current Field to Faucet and Ohio Board of Regent projects for applications that I mentioned before. While this research is very important, the next step is even more important, to take the research to applications to change what's happening on the fields and to maintain a safe drinking water supply. Continue to integrate research and extension at OSU with that of other organizations to accelerate improvements. Work to generate funding to support future Field to Faucet projects. So we don't just want to have these 5 projects, we want to have many more projects in the future, and we've already had some awards from some commercial seed operations to further our projects in Field to Faucet. We also want to develop a youth education component. Looking back at the history of Lake Erie's had problems since the 70s. It's been bad, it's been good, it's bad again. It's very important to get the youth involved in this, looking forward to the future so that we can maintain safe, swimmable Lake Erie and a productive food supply well into the future. And lastly, it's important to note that Ohio is not the only one experiencing harmful algal blooms. This is a problem that's impacting lakes and coastal areas across the globe. So as we develop new knowledge from Ohio, it's important for us to apply that knowledge to algal blooms across the globe, just as it's important for us to learn from other research and other applications being done to address these problems at other areas. So with that, I'll thank you for your time today. I will welcome you to contact me if you have any questions about this presentation. Contact me via email is probably the best way, martin.1130@osu.edu, and I thank you for your time.